Hello everyone, and welcome back. I'm Massimo, and I'm a member of Team MLG, together with Luca Bertelli and Gabriele Bonanno. We are working on GABER, our spoken keyword detection system on FPGA. Today, I will talk about the state-of-the-art of keyword detectors and the KPIs we will use in order to measure the development of our project. Let's now see how others have approached this problem. Today's spoken keyword detection used in voice assistant is implemented via software on a general-purpose computer. In the case of Amazon Alexa and Google Home, teardowns have revealed that the device contains an ARM Cortex. General-purpose processors seem to be the industry's standard right now and are used in most products on the market. The problems with these implementations appear because of the memory wall given by their architectures. The power consumed just for the memory accesses required to feed the operations necessary for the detection can easily exceed the power budget of a battery-powered device. Typical state-of-the-art keyword detectors rely on sophisticated convolutional neural networks, but these algorithms are simply not practical on platforms with limited resources. In order to address memory, processing, and power limitations of mobile devices, researchers have quantized model parameters down to values of 1 and 0 to create an architecture called a binarized neural network, or BNN. Let's now see the three KPIs that we will measure. These represent the three characteristics that our device must have in order for it to be comparable to the others already on the market. The KPIs we have chosen are power consumption, detection speed, and error rate. Power consumption is a fundamental metric because we want our project to be energy efficient and suitable also for mobile devices. The speed of the word spotting is measured as the capability of our system to detect the keyword in the smallest amount of time and must be higher than today's vocal assistants. The error rate defines the percentage of not recognized keyword and must be as small as possible, also in noisy environments. Let's see what are the parameters we can modify in our implementation to improve our KPIs. The first thing that affects our metrics is how the input is passed to our neural network. In fact, the input resolution and the audio sampling rate must not be too low, otherwise the error rate will increase, and not be too high, otherwise power consumption will increase. In order to reduce the number of features, we must pass the input data through a frequency filter bank. These filters must be correctly designed to minimize the quantization noise and filter dimensions. Even the filter weights have to be discretized during implementation, so the weights resolution could worsen the accuracy of the system. Finally, a larger number of filters could use too many resources, increasing the energy requirement. The second parameter that needs to be managed is the number of layers and neurons needed to implement our neural network. A large number of layers could increase the detection speed, since data is processed parallelly only in a single layer, while using too many neurons per layer could increase the number of resources used, despite the fact that both affect positively the precision of our system. The last parameter is how the neuron is implemented on FPGA. In particular, we must choose the right activation function. The ideal activation function is the sigmoid, but it's too expensive in terms of resources, so we must approximate it with a polynomial function. If we choose a high degree, we will increase the power consumption. If it's too low, it can raise the error rate. Of course, there are other activation functions, like the ReLU or the step function, but each has its pros and cons in terms of accuracy. By modifying these parameters, we wish to find the best trade-off that will allow us to improve the keyword spotting. Indeed, with our implementation on FPGA, we could be able to recognize the keyword directly without the need of the unnecessary hardware of a general-purpose computer, thus reducing power consumption and making it suitable also for today's portable devices. Thanks for watching and see you next time.